I start with the images of the scroll that Richard gave an excellent talk about it. And the whole project started less than a few months ago. So it's just in the beginning stage of a very, very exciting project. Okay, can we go? At Kyoto University, we have developed ultra-high resolution imaging systems, hardware and software, for applications in the field of cultural heritage. More than 30 systems are being used in Japan, Europe, Asia, and Africa on cultural heritage sites and museums. In this talk, we shall briefly show the history, technology, and some of the projects that have been carried out till December 2012, with users from more than 50 universities, museums, and broadcasting organizations. The large-size cultural heritage artifacts that were documented by these technologies include a wide range of Japanese, Chinese, Egyptian, Korean, and European objects. The criteria for scientific recording of world-class cultural heritage. That's what I want you to start our discussion. What is the criteria? First of all, high color fidelity, color difference of about 1.0 or 1.5. The minimal light irradiation. The museum people do not want to subject the 2,000 years old object with lots of light. So light is a critical point. High spatial resolution capable of detecting microscopic scale areas. Fast and cost effective to digitize hundreds and thousands of objects in museums and national libraries. Applicable to wide range of objects of various shapes, size, surface characteristics. For example, 2D, 3D objects, small to large and dark to shiny golden surfaces. Should be non-contact and non-invasive. Produce analytical information. For example, spectral or colorimetric. This is our criteria for when we start recording world-class cultural heritage and when we call it a scientific recording. The imaging techniques that can be performed with the systems that we developed at high to ultra-high resolution. The ultra-high resolution tricolorimetric is three-color. That's the normal images that we know about. And the color difference is quite low, about 1 order of magnitude better than any cameras or systems that you know. And near-infrared scanning, monochromatic or multi-spectral imaging. This multispectral imaging, we don't want to confine ourselves with 3 colors. We can do the imaging with 8 colors, 10 colors, and even more to have a more precise color. And then polarized light scanning for shiny objects, like golden objects. And then transmission and reflection light and 3D shapes. So this is a big menu for scanning. The analytical imaging system that we developed during the 10 years from now has 3 main parts. It has 3 main parts. It is the image grabbing system and using the images for analysis and also displaying the images that we have. It's, I think, better to Nina. Before going in more details, I would like you to see one of our main projects that we did last year. This temple is 400 years ago. It was never on public, and it's not on public now. They want to disassemble this temple and reassemble it again. So this is a big project. So before disassembling, we started recording the whole temple with microscopic level. Here you can see that inside the temple there are golden statue of Buddha, 1,000 hand Buddha, which is about 3 meters, and 30 smaller Buddha, the guardians Buddha, and the whole walls are painted 400 years ago. This period is the renaissance of Japanese culture. So it's very important for us to have a pigment database of this temple, which then we can use the database to find relation between this and the other major. Here you can see some signs of Donghua and the Chinese Buddhism in this temple. This is an emperor temple. It was, and still it's very much related to the emperor court. So this is, the real size of this object is about 1 centimeter. So we have a 100 times larger. It's 1 to 100. So most of these statues, they were not touched. So we had the dust for 20 years. So we had to clean the dust very carefully with specialists doing that. So it took us more than 3 weeks to clean. So we did 3-color scanning, infrared scanning, and multispectral scanning of the whole temple. This is some of the scenes of the scanning. We used about 10 different types of scanners which were designed and built for this case. So using infrared light, we could see the painting, underlaying painting. So this is a scanner. This is a scanner which is scanning the difficult parts of the temple, and it is about almost 10 meters. And the whole scanner was aligned with a 60 micrometer precision. The light sources, we use our own design light sources, our own developed, to make the light the minimal on the surface. So we had columns also to scan. This is a very difficult shape sculpture for scanning. This is one method of three-dimensional scanning. We also use the rotating sculptures. We rotated these sculptures, but in this case we could not do it because it's extremely fragile. So we rotated the scanner around the Buddha. And the whole statue is gold, so we should not have reflection on the surface. So we collected the database of the gold and the color of gold in this period. Okay, so this is a video clip that shows one of our most difficult projects. And the raw data that comes out of this project was 3 terabytes. And when it's processed, it will be about 100 terabytes. So it's an amazing, difficult project. So I would want to ask, but my museum friends do not need to answer, but when they say that they have, for example, 10,000 files, how big is their file in terabytes? Okay, now, next please. This shows our way of thinking about the light source. So the museum curators have kind of how many days they can put the objects on the display. So if we use that kind of criteria, when we do scanning for one scanner, we put the light on the irradiation on the object about a few percent of the museum light. Here the calculation is about less than 1%. So it's extremely low level of light, which is extremely important for us. Next, please. And I compared the linear and the camera, the area cameras to see what is the deformation and space accuracy, and vertical and horizontal direction. The red is the theoretical or ideal case, and this one is the scanner, and the blue is the one of the newest cameras on the market. So the distortion is more than a few pixels. So for people who care for this a few pixels, then it's important to use the line sensors. The next, please. Next. This gives a simulation of the why we should do the imaging in 600 dpi or 1000 dpi or 300 dpi. What is the criteria and how should we decide? So we made a simulation, and in 3 cases of the resolution, the object resolution and the image resolution are comparatively very high or very low. And here for high resolution images, you will have much less color mixture. Sorry, for high resolution, yes, for high resolution imaging, you will have very low level of color mixing, which gives you a much better color. So here, this shows this phenomenon. I can discuss this point when during the evening demonstration. Once we do scanning with high color fidelity, we can get the spectroscopic data of the points. So, okay, next, please. Going to the main subject, the scroll. Here you can see the scroll is 18 meters. It's about 55 centimeter, and we can go to this level of accuracy. And and here is the next, please. Here is the result of the spectral reconstruction. So we have the spectroscopy of different points of this scroll, and we will make a database of this scroll within 6 months from now, with all the scientific data inside too. Next, please. The development of these techniques, hardware and software, is the result of a few projects which was supported by the Japanese government, the Ministry of Education, and it started from 2004, but based on our activities, which goes a little bit beyond that period. And we had several projects for developing the scanner, developing the software, and recently using these scanners and this technology and the real world-class cultural sites in China and in other Asian countries and also in Africa. And we have some UNESCO projects at this moment. We established We established a few laboratories around Asia and Europe and China, and I think I don't have much time. I want to show the demonstration of the scrolls, and I will be for demonstration later this evening. Okay. This is the scroll. Okay, so this is almost the size that the real size. So you cannot. It's very difficult to see what it is inside. Okay, can we zoom in and zoom? Okay. Okay, here. So now this is about 30 or 50 times high, larger than the real size, and you can see there is almost no blurred point, and the quality of the images are also extremely good. So probably when Richard was making his presentation, there was some, you could not imagine that he was showing the objects that were only 2 centimeters high or 1 inch. So we have, this is the viewer that we developed in Kyoto with the help of a company. So we have all these kind of zooming function, and also we can measure the, okay, can you measure this? Okay, okay. So the whole face is in about 4 millimeters. So it's in extremely detailed. And here you can see it's in 600 dpi. It's still not the full resolution, 1200 dpi. And we hope that we can use the new 4K technology to show the beauty of this scroll in a better way. Okay, I think I don't have more time, so I would like to finish my talk without a conclusion, hoping that you will come to my presentation in alive. Thank you very much.
This is a question for you as well as for Mr. Lard, who presented earlier, as well as for the Dunhuang Academy. Among all these different imaging technologies, which all looks wonderful to an art historian's eye, can you comment on the advantages of each technology offers and the challenges that each technologies that also presents you?
Yes, if I am permitted to comment on also his presentation. I think it really depends on the place that you are doing the imaging. For example, if it is in a library or a museum, it's very different from a mural painting down 20 meters in Saqqara in Egypt that we did imaging to. And also in Tibet, I can imagine that Laird has a very, very difficult time, and it also, he was extremely brave to do this almost 20 years or 15 years ago. So the techniques, of course, they have advantage and disadvantage. If, for example, you compare the color fidelity, it might be 1 to 20 or 1 to 15, but it also depends on the situation and where do you do, and also why do you do the digitization. So this why is extremely important. I asked this morning one of our colleagues who was presenting, if, for example, you take a photo for marriage, it's much different from your passport, and the marriage should be much more beautiful. So what? But you know, the passport should be very real. So we emphasize on the reality of the object, the color, and even if it's not nice, we want to record the present precise status. So, and of course, then becomes the time you spend, the money you spend, everything should be compared to give a good answer to your question.
I completely agree. Just in brief, I developed field tools for remote locations. They're doing institutional work. And it's obvious, I mean, if you can have...
Both. We are
if
doing
we
both.
have both of these tools, I mean, it's really important. At Dunhuang, they have a set of tools similar to mine. And these tools work in different situations, in different ways, for different purposes. And as capturers, or whatever you're going to call us, as photographers, you have to pick your tool depending upon what you want to create, who it's for, and what tools you can use, and what funding you have.
Yeah. For example, the scroll we did in Hong Kong, practically more than 20 people were involved. It's not his case that he did everything by himself, one person. So these are the factors that are very important to compare.
And just as a reminder, Professor Ide will be at the laboratory this evening and will be able to answer more questions.